Students, let us solve this Irodov problem 1.23. A point moves rectilinearly with deceleration whose modulus depends on the velocity v of the particle as w equal to a root v. Okay, where a is a positive constant. Okay. At the initial moment, the velocity of the point is equal to v naught. What is the question? A particle is moving along a straight line. Rectilinearly means a straight line. Initially at t equal to 0, the velocity of particle is v naught and it is decelerating. Decelerating means the direction of acceleration and direction of velocity are opposite in direction. So velocity is in plus x direction means acceleration must be in minus x direction. And this acceleration w is not constant, it depends on velocity. So at any time t, if the velocity of particle is v, then the magnitude of acceleration w equal to a root v. Now what will happen? Velocity is in plus x direction and acceleration is in minus x direction. So the speed will decreases and after some time velocity becomes 0. Speed becomes 0. Now let me call that at this point the time is tau. Initially time t equal to 0 and this is the situation at any random time t. Now we have to calculate what distance will it traverse before it stop. So we have to calculate the distance between point A and point C. So this distance is called stopping distance. So first I have to calculate stopping distance. First part is to calculate the stopping distance. Now what is given? Acceleration w equal to a root v. This is the magnitude. Yes, definitely this is the magnitude, but the direction of acceleration is in this direction, so I write it as minus. Now minus, we can write acceleration w as v into dv by dx equal to a root v. Now this root v and this is a complete v, so it will become minus root v dv equal to dx should be transferred in right side to a dx. Now this is the equation. To find the distance x, we have to integrate this part. So minus integration of root v dv equal to a is a constant. So a should be outside the integration and the integration is of dx. Now initially x is 0. At initial point x is 0 and velocity is v naught. Okay. At the final point we have to calculate the value of x and the velocity is 0. So at final velocity is 0. So what is the integration of root v? It is v to the power 1 by 2 plus 1. So it is 3 by 2 divided by 1 by 2 plus 1. And this minus sign should be there. From where to where? It should be from v naught to 0 equal to, what is the integration of x? This is a simple x. From where to where? 0 to x. Now put this value. This is v to the power 3 by 2 and when we put 0 it should be 0. This is 3 by 2. So minus 2 by 3. This number should be outside and when we put 0, this is 0 minus when we put this number v naught to the power 3 by 2 should be equal to a into x. Now this minus and this minus will become plus. So 2 by 3 v naught to the power 3 by 2 should be equal to a into x. So what is the value of x? X equal to 2 by 3a into V naught to the power 3 by 2. So my first answer, the distance traveled before it stop is, so x equal to 2 by 3a into V naught to the power 3 by 2. So the first answer is this. Now, in the second part, we have to calculate the time taken by the particle from this point to this point. This is called stopping time. This is called stopping time. So, in this part, we have to include the time, not the position. We should do our calculation such that time is the part of our equation. So, stopping time. So, what is given? Again, minus w equal to a into root v. But we have to include time. So, I write this equation of acceleration as dv by dt. And it is equal to a into root v. Now, rearrange the equation. So, minus dv by root v should be equal to a into dt. Now, integrate this function. So, minus integration of dv by root v equal to a is a constant, integration of dt. Now, put the limit at t equal to 0. At t equal to 0, initial velocity is v naught. So, it is v naught. At final time tau, velocity is 0. So, I have to integrate this part. Now, what is this? This is v to the power minus 1 by 2. So, the integration of this part, v to the power minus 1 by 2, it is v to the power minus 1 by 2 plus 1 divided by minus 1 by 2 plus 1. From where to where? It should be from v naught to 0. And integration of dt, it is simply time t. From where to where? It is from 0 to time tau. Now, 1 minus 1 by 2, it is 1 by 2. So, 2 go in upper part. So, 2 into v to the power 1 by 2. From where to where? V naught to 0 should be equal to a, and this is simply tau minus 0. Now, when we put 0, it is 0. So, minus 2 into 0 minus, this is nothing but a root v. Root v naught equal to a into tau. So, again, this minus and this minus becomes plus. So, 2 into under root v naught should be equal to a into tau. So, tau equal to 2 by a into root v naught. So, my answer is the time taken by the particle to stop is 2 by a into under root v naught. So, the answer of first part is this, and the answer of second part is this. Now, why I should this minus sign? This is because both these parts are opposite in direction, and this is not acceleration, this is the magnitude of acceleration. So, if velocity is positive, then acceleration is negative. So, what I write as acceleration equal to minus w. It is not a root v. So, acceleration a should be equal to minus a into root v, or in this question acceleration is written in form of w. So, w equal to minus a root v. So, because of this nature, there should be a minus sign.